Hello, this lesson is titled More Than Four Sides of the Story, and it's part two of finding the volume and surface area of prisms and pyramids. So we're going to jump right back in and have a look at what we were talking about before, which is regardless of the type of prism that you have or the type of pyramid that you have, these formulas will always work for the volume of the prism or the pyramid, regardless of the type of prism or pyramid that you're looking at. So in this case, these are hexagonal prisms and hexagonal pyramids. But the formulas that we were using before for rectangular and triangular prisms and pyramids still apply exactly the same. Also, the same thing for the surface area, which is kind of cool. So regardless of your prism or pyramid, these formulas are going to take care of us in finding the volume and surface area. So here's the one catch. We'll need to find the area of the base, which is now in these shapes a hexagon. And up to this point, I don't know that we've ever calculated the area of a hexagon or an octagon, but we're now going to take a look at a technique that's going to allow us to do that. And this technique is going to apply when we have a regular polygon. And a reminder, a regular polygon is a polygon where all of the sides and all of the angles are the same. And so the regular polygon that most people are familiar with is the square, which has 4 equal sides and 4 congruent right angles. This here is a regular pentagon, 5 congruent sides and angles, and a regular hexagon. So the technique that we're going to explore today involves breaking up these regular polygons into smaller triangles, because we know how to find the area of a triangle using this formula, 1/2 base times height. So now what we're going to do is we're going to take these regular polygons. Let's start with the square, which we already know how to find the area of, length times width, and go through how this works. If we can find the area of this gray triangle right here, then we can find the area of the square by taking this one area and multiplying it by 4, because there are 4 of those triangles inside of this square. Same thing for the pentagon. If we can find the area of this one triangle, and then we realize there are 5 of them, the area of this pentagon can be calculated by multiplying that gray triangle by 5. Similarly for the hexagon, we know that one, and there are 6 of them. Then the area of the entire hexagon is 6 times the area of that gray triangle. Make sense? Okay, quick review. So what we just looked at was this idea of a regular polygon, and that's a polygon where all the sides and all the angles are congruent. And then we looked at how we can find the area of a regular polygon by breaking it up into these little triangular sections. Let's see if we can apply that to a problem. So the problem that we're going to look at is trying to find the volume of this hexagonal prism. Kind of looks like a water tower maybe, but it's pretty small. It's only 12 centimeters and 20 centimeters high, but it has that shape. So we're going to try to find the volume of this prism by first finding the area of the base and then using the formula for the volume of the prism. So here we go. We're going to start with this first part right here, find the area of the hexagonal base. And we're going to do it just the way we talked about last time. Since we see there's a triangle section identified here, and we know there are 6 of them in this hexagonal base, we're going to start by just finding the area of that 1. 1/2 times the area of the base of this triangle, which is 12, since all of the sides of this hexagon are 12, times the height of this triangle, which is actually being pointed to by this little arrow, which is 15. That's the area of this one triangle. So, little mental math, really fast. Half of 12 is 6, times 15 is 90. That's the area of that one little triangle piece. But we said there are 6 of those. 1, 2, 3, 4, 5, 6 of those in this hexagonal base. So we're going to take that and multiply it by 6, and that will give us our area of our base. 90 times 6 is 540. 9 times 6 is 54. So that takes care of step 1. That is the area of our base. That's important because now we can use that number in our formula for the volume, because the volume, according to this formula right here, is the area of the base, 540, times the height. And the height of this hexagonal prism is 20 centimeters. It's the red line going from the bottom base to the top base. So that's it. That's all we need to do for the volume. Now, I am going to use my calculator real fast to grab that. And here we go. 540 times 20 equals 10,800. Thank you to the Mr. Calculator. That's 540 times 20, and that is the volume of this prism, this hexagonal prism. Important to remember always to put your units on there. Since we're talking volume, this is going to be cubic. And since we were talking centimeters before, this is cubic centimeters. And that is how you calculate the volume of a hexagonal prism, 10,800 cubic centimeters. And that brings us to the end of our lesson on calculating the volume and surface area of prisms and pyramids. Thank you very much for your time. Bye-bye.